Okay, so you can now ask your doubts on this chapter or any previous chapter. Hmm. Yes. Hmm. 5 kg and its specific gravity means its density. So that density is how much given? Specific gravity 3. So specific gravity is the ratio of density of object and density of water. So density of object is 3 times density of water. If I take SI unit, water density is 1000. So this becomes 3000 kg per meter cube. Okay, that's what it is. So the question is how much work is done to raise this body from the bottom of some lake is there, and you want to raise it 5 meters. You want to raise it inside the water only, right? So first of all, you need to this question is a multi-concept question because this question involves the concept of force of buoyancy. Okay, force of buoyancy. So first of all, you should note that there is a force of buoyancy act on an object when it is inside water or any liquid. So mg is anyway acting, but there is a force of buoyancy, or it is also called upthrust. 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 So this upthrust force is given as volume which is inside, volume inside into density of the outside liquid medium into G. Okay, that is the formula for upthrust. Upthrust is volume inside. Volume inside means how much body is inside the water or inside. Here total volume is object is completely immersed, right? Total object is completely immersed. So this volume immersed is same as the volume of object because total volume is immersed. Volume of object, it is same as volume of object. And we know density is equal to mass by volume, volume of object. So volume of object can be written as mass by density of object. So if you use this volume inside, it's same as volume of the object. Volume of object is mass by density. So if you use here, this become mass by density of object. This is density of liquid into G. So from here you can see the upthrust formula. Upthrust formula comes as mg into density of liquid by density of the object. Okay, this is the formula for upthrust. Now here, what is the liquid? Liquid is water only, right? So upthrust is equal to mg into density of water by object, and this density of water by object, this is like 1 by specific gravity, right? So this is 1 by specific gravity, which is given as 3. So the upthrust is equal to mg divided by 3. Okay, this is first we have to understand that. So the upthrust which is going to act in water, that is mg by 3. So what are the two forces acting on this body? One is mg and another is upthrust. This upthrust is mg by 3. So now what is the total force going to act downward? Downward, how much is the total force now? So this is mg minus mg by 3. This becomes 2 mg by 3. This is actually the weight of the body inside the water. Okay, you know the weight decreases, right? Why the weight decreases? Because of the upthrust. Okay, yes. So this is what is called effective weight. This is called apparent weight or effective weight. Effective weight. Effective weight is mg minus force of upthrust or force of buoyancy. That is 2 mg by 3. Now suppose if you want to lift this body, yes. That is Archimedes principle only. This is Archimedes only. Upthrust. The upthrust is what because how to calculate upthrust, that is given by Archimedes principle, right? So upthrust formula is Archimedes principle only. This is Archimedes. This upthrust, this formula, this is Archimedes principle. How much is the upthrust acting? That depends on volume inside and density of liquid and G, right? So volume inside means total object is inside. So that is volume of the object into density of liquid. Actually, this upthrust is the weight of liquid displaced, right? How much weight is liquid it is displacing. So weight of liquid displaced is mass of liquid displaced into G. Mass of liquid displaced into G. So mass of liquid displaced is volume of liquid displaced into density of liquid. Volume of liquid displaced means how much object is inside the liquid. That is volume immersed. That volume is total volume of object. Suppose the object is half submerged. Half submerged means then volume will be half, right? Vi will be half. But here total volume is immersed. Okay, so this concept is coming from Archimedes principle or force of buoyancy, right? So this effective weight formula is coming here as 2 mg by c. That means this is the weight of this body inside water, 2 mg by 3. Okay. Now, if you want to lift it up, so to lift it up, you have to apply this much force only, correct, right? If you want to lift this body up, you have to apply a force which is equal to effective weight of this body. Effective weight here is 2 mg by 3. So that means if you slowly want to lift up, you have to apply the same 2 by 3 mg. Slowly means you are keeping it equilibrium. Very slowly you are lifting it. You are keeping it equilibrium. So you need to apply this force. Now you calculate work done by this force. The work done by this force is force into dot product of force and displacement, and you are keeping displacement in the same direction, force and displacement. So force into displacement means height, right? Force into height. How much height? How much height you are putting? 5 meters, correct? So substitute here. So 2 by 3 mg into 5. Substitute. Mass they have given, no? 5 kg. Mass is 5 kg. G is how much they have given? Did they give G as 10 or not? Otherwise, approximately you can calculate. You take G as 10, you calculate. 5, 5, 20, 5, 5, 20. And then you have to calculate exactly then. Okay. Then you calculate 2 by 3, 5 into 9.8 into 5. 5, 5, 25 into 2, 50, 50 into 9.8 by 9.8. So this 10 you remove, 10, 10 bit cancels. 8 into 5, 40, 4, 9 into 5, 45, 490 by 3. So 3, 1, 3, 6, 18, 163.33. Correct? Check this answer. Joule. Okay, that is the answer. But this is out of syllabus right now because this topic will come in fluid mechanics. So right now you can leave it. Okay, 1 minute. Question number 22. Hmm. An object is acted on by retarding force of 10 Newton. A particular instantaneous kinetic energy is this. Suppose there is an object and it is having right now a kinetic energy of 6 joule. And retarding force means what? Its force will be acting like this way. Motion is happening, velocity is in this direction, force will be opposite. This force is 10 Newton. Okay. Objective. Oh, question number 22 it is. By applying the brakes without causing a skid, the driver of a car is able to stop the car within a distance. So, same way, this body or this car is there. Skid means no sliding is happening. So, this body was moving with some velocity. Let us say you finally this is going to stop because brakes are applied and it stops. Final velocity is 0. Okay. Stop the car. And how much is distance traveled? 5 meters before it stops. If it is going on with a initial velocity that is given here, 36 kilometers per hour, convert into 5 by 18, that become 10 meters per second. Okay. Okay. If the car were going with 72, he can stop the car over. Stopping distance. This formula directly use stopping distance. What is the formula for stopping distance? Tell me. Stopping distance formula. Okay. Over now. And x is equal to u squared by 2a. A is the retardation. Retardation. Now they are saying that what will happen if you change the speed? If you make double. So if you make speed double from 36 kilometer per hour to 72 kilometer per hour. So tell me, how will x will change because x is proportional to u square. So tell me, if you double speed, what will be x? 4 times over. You got the answer. Here right now x is 5 meters, right? Now it will become 4 times. 4 times means 4 into 5. 20 meters. That is the answer. Okay. No, time is not playing because we are not calculating time. If we ask time, then you calculate time. They are asking distance. How much distance is stopping distance? Because acceleration is constant now. The brake force of the friction and those things are constant. Then if they ask time, so previously how much time was there and now how much time will be there? They ask how much time will stopping time you tell me formula, stopping time formula. Stopping time is u by t, right? U by a, u by a, u by a. Now what will be stopping time? It will become double. You can calculate stopping time in each case. First case stopping time, let us say stopping time is t1. They should give that time in the question, how much time it stops. Or you can calculate time also because you can use v equal to u plus at, correct? Yes, you can use v equal to u plus at. So if you use velocity is 0, retardation line, so minus, let us write minus this. Retardation is. So final velocity 0, initial velocity in a meter per second 10, acceleration retardation, but that is not given, no retardation. Uh, Distance is given. So how do you calculate? Ut plus half a t. What? But why we need acceleration? With time we want, not time. Then you use x is ut plus half a t square minus half a t square. This you use better. Okay, stopping time you calculate. Uh, what will be stopping time? Apply that. Oh, both are unknown now. Then acceleration you calculate. Acceleration you have to calculate them, right? So v square is equal to u square minus 2ax. Okay, calculate acceleration then. U square minus v square by 2x. So tan square finally 0 only. 2 into 5. 100 by 10, 10. Okay, acceleration or retardation is 10 meter per second. Then time you can calculate it. Then you can use v equal to u plus at. So time is u by a you can now apply. So initial velocity is 10 plus 10. So 1 second. Now if you double the speed, what will happen? Same formula u by a, but now u is double now 20 meter per second it will be. Then it will stop in 2 seconds. Correct? Right? If they ask the stopping time, then you calculate. Next. Any other doubts you have? Ask questions. What? What? That we will discuss next. That is next topic. Conservative and conservative is next upcoming topics tomorrow. We'll discuss. Then module questions are you not completing? Module questions up to exercise 1, 2, 3, 4, 5, 6 previous topics. Hmm. Up to 15 completed. Huh? Okay, let me check some questions. If I have any questions, then let me check some questions. I have got some Olympiad level books. Okay, let me check out some questions on work, power, energy. Hmm. Okay, let's try one question on this. But I don't want to take too much difficult question. Fewer questions looks like. Okay, let us try this question. Integer type question. These questions are very advanced model questions. Consider the system shown in figure with two equal masses. Mass is given as 1 kg. The spring constant. This spring constant is given as 800 Newton per meter. Coefficient of friction. Here there is a coefficient of friction mu is 0.2. Pulley's frictionless system is held with a spring at its relaxed length and then released. Find maximum displacement of the block in subsequent motion. Maximum displacement. Hmm. What about right, dragging it is? I think one minute. Board you are able to see clearly or not? One minute I will refresh it. Now are you able to see the board? Okay. Okay, so might be some network issue might be there. Okay, so suppose there is a block which is connected with a spring, and let us say initially there is no elongation in the spring, and then you release this blocks. As soon as you release the block, this will start elongating, right? The spring will elongate. Why? Because this block will fall down, that will go this side, so spring will start elongating. Question is, what is maximum elongation? That is the question. Okay, maximum displacement. Find the maximum displacement of the block. Maximum displacement of the block means maximum elongation will happen. That is the question, right? Find maximum displacement of block. Find maximum displacement of block. So this question means we need to find out maximum, because maximum elongation happen means maximum displacement will happen. So that means it is maximum elongation in the spring you calculate. Maximum elongation in spring. This is a JEE advanced level question. But it can be done based on energy conservation, based on work energy theorem. We can solve this question. Think about it. Assume that this is quite lengthy. Don't think that it will hit in this pulley. Okay, you assume that this is quite sufficiently large. Okay, don't think that it will be hitting in the pulley. You can draw a proper diagram and assume that this is quite long. Okay. This string is quite long. Okay. So how are we going to think about it? Hmm? Hmm. Correct. Because it will go maximum elongation whenever it happens, the blocks will stop in maximum elongation. After that, it can come back, it can start oscillating also, just like in a spring. So you assume that when maximum displacement happens, this block will have instantaneously zero speed, or it will stop at that moment. So let us try to think about it. Suppose it goes a maximum distance x this side. This will also go maximum distance x this side. The spring will elongate, right? Uh, so the block will come down. So because here, not here, as this block comes down, there is a gravitational potential energy also changing. But here this block gravitation is not changing because it is same height. It is horizontal surface. Okay, so let us assume that block has come here. This block has come here, and this block has come somewhere here. Let us see. Okay, so this system will be like this. Okay. Now the thing is that apply the energy, and spring has what elongation? This axis is the spring elongation. So now let us try to apply energy conservation. So initially, what is total energy of this system and what is total energy in this system final? We will equate that. So initially there was no kinetic energy. This was starting. This was also starting. So kinetic energy plus potential energy, gravitation plus potential energy spring, because there are two types of potential energy, right? Okay. Similarly, kinetic energy plus gravitation potential energy plus spring potential energy. We will write this both initial and final. So initial kinetic energy is 0 because blocks are not moving. And note that final kinetic energy also will become 0. So kinetic energy initial and final will be 0. Potential energy initial. Suppose I choose this level as a reference level. Okay, reference level I will choose this. If I choose this as reference level, then uh, then let us say that initially this block was at height h1, and this second block after that it comes to height h2. Okay, so let us write the potential energy gravitation of this system. So this gravitation potential energy is 0 because this reference level is 0, but this is minus mgh1. So you have to write for this potential energy gravitation as minus mgh1. And spring also has no energy initially, so spring energy is 0. So this is the total energy of this system, right? Because no kinetic energy, gravitation energy only in this lower block minus mgh1, and there is no spring energy. Finally, kinetic energy also 0. Gravitation potential energy, again this has reference level, this is no energy, but this energy will be minus mgh2, minus mgh2. But now spring also has energy, which is half kx square, half kx square. Now let us try to solve this. X we have to solve. How to solve? And note here that h2 minus h1 is equal to x, that you note. H2 minus h1 is x. So from here I will bring this side. Again it is becoming. What about from your side? Ca- can you refresh your side? Please refresh from your side. Please rejoin this session. No, no, because sometimes networks lags from both sides. Both side network issues are there sometimes. Hmm. Network issues from both sides it happens. Okay. Anyway, so let us try this. So h2 minus h1 is x. Now you solve it. You bring this side. Mg h2 minus h1 is equal to half k x square. So mg h2 minus h1 is x. This is half k x square. So from here x can be cancelled. One x will get cancelled. So mg is equal to kx by 2. So x will become 2mg by k. Let us substitute and solve that x. 2mg. What was the mass? 1 kg. 1. Let us take G as 10 to mg by k. K they have given 800. So x must be uh, 1 by 40 meters. What is the answer? Let me check that. Oh, but one thing we forgot. Friction was also there now. If the surface was smooth, if surface was smooth, then this is the correct answer. We did not take friction, right? Okay, if the surface is smooth, then this is the answer. Oh, but surface is rough, then what to do? Surface is rough. Oh, how to do that? Friction. Friction we have to do. Friction we have to consider. That means now you cannot use energy conservation. You have to think of work energy theorem. Work energy theorem you have to think. Hmm. So let us think about work energy theorem. This is a very good example of work energy theorem. Work energy theorem. So what does work energy theorem? Ah, yes. Because initial kinetic energy is 0, final kinetic energy is also 0. So system has final and initial 0, 0. So this is 0 minus 0. That is what is 0. So work done by all the forces. Now what forces? What work is acting? Now you think about it. So the spring is applying. Correct, correct. So you think about it. What are the forces acting on both the bodies? Okay, on the system you are taking. On the system you are taking, you are seeking system. System you are taking. Okay. So suppose if you study on the first body, uh, tension will be acting, right? And this spring force will be acting like this way at an instant kx, and as the body is moving this way, friction must be acting like this. Okay. Friction will be acting like this. On the second body, tension will be acting like this, and mg will be acting like this. Okay. So work done by forces on this body plus work done by forces on that body, total body, or individual bodies also we can study, right? Isn't it? Because even if you study this block is initially rest, finally also rest. You may study individual blocks also, that is not a problem. Hmm. So, how to study? Hmm. Let us try on first body and second body both, okay? Because both bodies start from rest and become rest finally. So let us take both the bodies. This body I will take first body. So here tension is acting and friction is acting and spring force kx is acting. Magnitude of spring force like this way. So on this body, work done by spring force, and that is spring, work done by spring plus work done by friction plus work done by tension is equal to 0, because its kinetic energy is also going from 0 to 0, right? So that's one thing. So let's try that. Work done by spring is a variable force, you know that, and spring force is acting this way and displacement is happening this way. Let us take a small displacement dx, because force is a variable. So you will do the integration. Spring force is this way, displacement is this way, so you have to write minus kx dx. Are you getting this? Yes, minus kx, because cos 180 degree, cos 180 degree minus 1. Are you getting that? Yes. So this is spring force work by this. Now we are not taking spring energy. We are not studying spring energy conservation. We are not doing now. We are doing calculating the work done by each forces, change of kinetic energy. Now we are not doing energy conservation. Okay. So work by spring force is minus kx into dx because spring force acts this way, dx happen this way. And we know that total displacement is 0 to x, so we know the limit 0 to x, that limit we know. Okay. And friction force is going to be constant force, you know that, right? Friction is going to be constant, right? Mu times normal. Yes, mu times normal is mg. So this is, and friction is constant, so here, and friction is opposite of displacement. So for this we can write work done by friction is minus f into x. Directly we can write, because force is a constant force and angle between friction and displacement is 180 degree, that we can write directly. Okay. Then work done by tension we do not know, and tension may be changing also. So so you just leave it like this. Work done by tension is tension into dx. Tension, and which direction tension act? Tension is acting this way and displacement is also happening. So it's plus t dx. It is not minus t dx because they are acting in same direction. Correct? Yes. Clear? This equation is clear. Yes. Gravity, you're correct. You're correct. Gravity is doing work or not? Tell me. Mg is acting like this way, but displacement is happening this way. Is there any work done by gravity on this body? First block. No. Normal. Uh, uh, on first block, normal and mg is not doing any work. So we don't have to count normal and mg. Clear? Right? But second block will come. Don't worry. Second block will come. First we are writing for first block. Right? So on the first block, mg and normal will not do any work. Okay. This is equation. Let us little bit simplify this. So if I take k minus k constant x integration x square by 2 and limit you will go from 0 to x. So this will come x square by 2 on. Okay. This is minus friction, which is mu times normal mu mg into x will come. But this we do not know, leave it as it is. Leave it as it is. This is equation number 1. Okay. Equation number 1, and then we will go to the second block. Let us study that block. So on this block, forces acting is mg and forces acting is tensor. And this block is also having a displacement of x, and here also its speed initially 0, final speed is also 0. Let us apply work energy theorem. So work done by only these two forces, so work done by tension and work done by mg is equal to 0, because kinetic energy is also not changing here. Kinetic energy change is also 0. Apply this. Now note here, very important thing, tension is acting this way but displacement is like this way. So the angle between tension and displacement is 180 degree, and tension will be a variable force because spring force is changing. So it is, you have to write minus t dx. This is, you have to understand, minus t dx you have to write, because tension, if you do not know, just write integration tension. If tension is constant, will come out of integration, but we do not know anything about tension, so write it like this. Now mg, we know it's a constant force. No, no, mg is this way, displacement also this way. So both is in same direction, and it's a constant force. So plus mg into x, that's all. Mg into x, this is 0. So from here we are getting this from second equation we will substitute and we can solve. You got the idea, right? From here we got integration t dx equal to because tension is opposite now. Tension and displacement are opposite. Tension is upward, displacement is downward. So minus t dx. It's dot product now. What is dot product? T dot dr vector. So magnitude of tension, magnitude of displacement, which is dx, and cos 180 degrees minus 1. That's why it is minus t dx. Are you understanding this? But for that block, it was plus t dx. Why? Because tension and displacement was in same direction. That's, that's what. Now you solve. Now this one you substitute in the first equation and solve this. So t dx from here, from first equation, this t dx is equal to kx square by 2 plus mu mgx, and from here this is mgx. So let us now substitute and solve. Now we have to just do computation. Mgx is equal to kx square by 2 plus mu mgx. X terms can be cancelled x. Mass will remain, okay, keep it, mg is equal to kx by 2 plus mu mg. Now calculate, I think now we got it, answer, right? So kx by 2, this mg terms bring this side, so mg 1 minus mu. So x will become equal to 2 mg 1 minus mu by k. Now let us substitute the values and check out the answer. 2 times mass was 1 g, let us take 10, 1 minus mu was how much? 0.2, 0.2 it was. Okay, so substitute that 0.2, k was 800, right? Okay, substitute. So this will become 0.8 by 800. We remove this 10 decimal, this 10 will give away, 8 will cancel by 100 times. So this is 2 by 100 meters, and this is going to give us 2 centimeters. Yes, because you multiply this with 100, you will get centimeters. So this is the answer, very good answer. This is the answer for this. In centimeter, it's an integer type of question. They are asking in centimeters. Clear? JEE advanced type. Question number total of 17 or 18 questions are there in JEE advanced, and you have sufficient time. All three subjects you will have. There are two papers are there. First paper, second paper. Both paper, all the three subjects are there. Three hours are there. You can give 5 to 6 minutes or 10 minutes also. You can give. Out of 16 questions, if you can solve 10 questions in 1 hour, you can become the topper also. That means you can get all India rank within 100 also. It is a very tough level of questions. Some questions may be easy, not that all questions will be tough. Some questions are easy questions also. Some questions in advance are like main layer questions. Some questions are easy questions, but most of the questions, 50 to 60% questions are tough level questions. Okay. So if you can score out of 360, total marks is around 360. Out of 360, if you can score 200 marks, means you can get all India rank within 2000 or 3000. You can get. And if you score nearly 300, then you may get nearly within 1000 or within 500 also you can get all India rank. That is possible. Hmm. Your seniors, those who have scored within 10,000 or within 6,000, 7,000, they have got out of 360 marks nearly, they have got 145 or 150 marks. 150 or 160 marks they have got. Each subject will have cutoff, but If you can get like good cutoff, then it's possible. Like if you can get out of nearly 80, 90 marks, if you can get, that will be very good score. That total marks also changes every time. Paper pattern are not always fixed. But let us say average marks is 120. So out of 120, 80 questions, if you can do 80 marks, if you can get, it's a very good score, right? Or even if you get 60 also, 60 marks also, if you get, it's a very good score, right? 60 marks also, almost 50% if you can do, that is also very good score. No, 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 not modules. Modules are only for JEE main, JEE main only. Advanced, you need to go further. You have to solve different types of books, but first you get a good score in, and then if you are interested, then you can solve Erodo, you can solve Pathfinder, you can solve um, John Calde, foreign authors, international Olympiad levels. So, right, there are so many things, but for that, right now, if you take those questions, you will, your mind will boggle. Like, what is this? Occasionally, only you can solve such questions. So, weekly, you can target 5, 6 questions, or daily one questions, like that. Because you don't have much experience, you have to first get the experience of basic level of questions, right? Then only you can solve. So this book which I have right now, book which is, it's an international level JEE advanced and Olympiad level book. This is Anurag Mishra, Numerical Odyssey by Anurag Mishra. Recently I got a volume of this. Anurag Mishra is a very good author. He has been the faculty at Kota for almost 30 years. Now he has retired and he has written these books. Anurag Mishra. Right, so there are a lot of good questions are there. One question we solved on this, then another type of questions. Okay, let's try one more question. It's a multi-correct question. Multi-correct means more than one options are correct. So an object of mass 2 kg is left to move along a horizontal surface. So there is an object of mass 2 kg and it is allowed to leave so that it can move on the surface. Friction is not there, so you can take the surface as a smooth surface. At one moment, its kinetic energy is, at one moment, at some instant, it has a kinetic energy of 900 joule, 900 joule, and 2 seconds later, it is only 400. That means after 2 seconds, that means it is moving, it is under motion. So where it is moving, we do not know, but after 2 seconds, its kinetic energy is only 400 joule. And this happens in 2 seconds. 2 seconds. Okay. While the object covers, they have given it is reducing. They are not giving which. They have not given where the what forces that you have to think about it. Some forces are acting, not acting. That you have to think about it. But its kinetic energy is decreasing due to some reason. It is happening, and this happens in 2 seconds. And during this time, it is covering a distance of L. L is the distance covered. Now you have to think about it. The options they have given. First option, they are saying that object stops after covering a distance of 40 meter after covering initial distance. So they are saying that after this, it stops. It stops after some time, and they are saying that this distance to stop is given as 40 meters. Is this correct or not? This is option, first option. So first check this. Check whether this option is correct. They are saying that after now 40-meter traveling, it will stop. That means kinetic energy will become zero. Is this correct or not? Check first. You think of work energy theorem. Think about work energy theorem. No, that is not given. Time only is given for vector. No, no, I think they are saying friction is not negligible. No, no, friction is there. I misread the question. Friction is there. They are saying friction is not negligible. Friction is not negligible means friction is there. Oh, that means there is no other forces acting. Friction is the only acting forces. Okay. That means this body is moving and due to friction, its speed is decreasing. Okay. So after 2 seconds, its speed has become 400 joule. So after some time, it will stop. So what is the distance after which it will stop? That distance, stopping distance, you find out. So I think this is now easy, right? Because we can apply, we can calculate acceleration using kinematics, right? Acceleration we can calculate. How can we calculate acceleration? Initial kinetic energy is given, final kinetic energy. V square equal to u square plus 2x we can use. Or work energy theorem you can apply. What is work energy theorem? Work done is change of kinetic energy, correct? Right? Work done is change of kinetic energy. Work done change of kinetic. Well, friction we do not know. Distance L also we do not know. Distance is not given. Time is given. Time is given means v equal to u plus it. No, time is given. U is given. V is given because kinetic energies are given. We can calculate u and v. U is given. V is given. Time is given. Acceleration we can calculate, right? V equal to u plus at. We can use an acceleration. We can calculate v minus u by t. So V we can calculate because kinetic energies are given. So first calculate U and V. So half m U square is 900. So mass is 2. 2 will get cancelled. So U square is 900. So U will become 30. Similarly, half m V square is equal to 400. 2 to get cancelled, V become 20. Okay, so retardation is there, we know that. So it will come anyway retardation because 20 minus 30 by 2, so minus 10 minus 5, correct? Retardation is there, right? Minus 5 meter per second is for retardation. Okay, then now if you know retardation, if you know speed, can you calculate this distance? Can you calculate this distance to stop? Because retardation is how much? Retardation. Retardation will be 5 only because minus we will not take. Ah, yeah, minus will remove, that is 5 retardation. And this speed here is how much? 20 meter per second. Can you calculate stopping stopping distance? Calculate fast. U square by 2a. Check out. So 20 square by 2 into 5. Is it correct? 400. Coming na? 40 meters. Yes, that means this option is correct. This option which is saying that 40 meter it will stop, this is correct option, right? This option is correct. Next option, what is that? The object takes 4 seconds to stop after covering. Okay, now they are saying stopping time. How much time it takes to stop? Stopping time, you calculate U by A. Calculate fast. Stopping time. Stopping time is U by A. How much is stopping? U is 20. A is 5. 4 seconds. Is it correct option? Yes, this is also correct option. Stopping time is this, right? Okay. And then, okay. Friction coefficient between the object and surface is 1. Friction coefficient because acceleration is mu times g. You remember, due to friction acceleration is mu times g. Use this now. Use this now. Acceleration we have retardation is 5. Mu g if I take as 10, then mu will be nearly 0.5. Yes, this is correct. Friction coefficient and the surface. No, this option is not given. They are saying mu is 1, which is wrong. So mu is, the third option is not becoming. L they are asking. What will be L? They are saying L is 50 meter. Check whether L is correct or not. L is 50 meter or not? Check. We can use v square equal to u square plus 2ax, right? U square minus plus 2a. L. A is negative here because it's retardation. We can substitute. So what will be L? L will be v square minus u square by 2a. Here we will use proper sign. Okay, because a we have calculated. Proper sign you use. So finally speed was 20 square minus 30 square by acceleration is minus 5. So calculate this. This is 10 minus, and this will be 30 square minus 20 square. How much is L? Calculate. 900 minus 400 by 10. 50 meter is correct, right? Yes. This option is correct. So option A, B, D. Three options are correct. Third option is not correct. Got it? So there are questions of JEE Advanced which have more than one correct answer. Of course, this question we solved using kinematics. We did not use work power energy. Work energy, although you may think of also work energy, you can also try, because work energy also involves kinematics only. Work energy theorem involves uh, force into displacement and all that. You can do those factors. Fine. So let us wind up today's session. We have discussed few advanced questions we have discussed, and keep your doubts whenever you are coming. You bring your doubts, as many doubts you can ask as possible. For that you have to solve many questions. Okay, so keep on solving questions. Fine, then we'll see next class, right? I hear. Okay. Okay. Yeah. Bye bye. Yeah. Modules only you work out, and PYQs also you can see. Previous year question J main see. You have question bank, otherwise you can refer to Math on Go site. Math on Go website is a good website. They are giving all the recent year questions of J main, topic wise also they give. So Math on Go website, it is a good website. You can refer that. Okay.